This video is for Module 2, Part 6, and includes a discussion of the Semantic Memory case study. Okay, let's go ahead and get started. Semantic memory is the memory responsible for our ability to retain knowledge or facts that occur throughout life. Semantic learning is influenced by our life experiences and also the culture in which we live. Now, the hippocampus, which is located in the temporal lobe of the human brain, is responsible for the consolidation of this type of knowledge. If the hippocampus is damaged in some way, then an individual's ability to acquire new semantic knowledge may be reduced. Okay, let's talk about example 2.6.1. Bailey provides a discussion of a patient EP, who in 1992 suffered substantial memory loss after contracting viral encephalitis. So this damaged patient EP's hippocampus. Bailey conducted a series of memory tests to assess the semantic knowledge gained by patient EP since 1992. The outcome from 3 of those tests are going to be considered here. So the 3 memory tests considered here are the new vocabulary test, the famous names test, and also the famous faces test. For each of these tests, there were 9 possible choices for each test item. There was 1 correct response and 8 incorrect responses. The number of trials is provided here in the table. You can see we had 25 trials for the new vocabulary test, 24 trials for the famous names test, and 25 for the famous faces test. The number correct by EP were 5, 1, and 6 here. So let's consider the famous faces test for a minute. So here's a correct test item. Here's an example test item. So we're going to provide or show patient EP a photo of somebody that has become famous since 1992. So for example, maybe Brad Pitt. There's going to be 8 other photos of non-famous people, and we're just going to simply ask patient EP to be able to identify which of these 9 people is a famous person. Now it's important that they've become famous since 1992 because that was after the loss of that semantic memory by patient EP. Again, there were a total of 25 trials, and patient EP got 6 correct on that famous faces test. Here's a short video that I found on YouTube of patient EP. It's pretty interesting in that you can tell that his long-term memory is fine, but knowledge gained since 1992 is hard for this individual to try to retain or recall. Okay, let us consider the research question here then. So is there enough evidence to say that patient EP has the ability to recall faces of people who have become famous since 1992? So the research question here gets put into the HA, and the HA again here is patient EP does have the ability to recall. Okay, so we're asking whether or not patient EP has regained some ability to some semantic memory ability, I guess. The null hypothesis is that patient EP does not have the ability. The parameter here is going to be just the probability of getting a test item correct. Here's a schematic of the reference distribution. The reference distribution is going to go from 0 up to 25. Just going to keep track of the number of correct. Now this reference distribution is not up the number line very far because there's 9 possible choices. So the parameter value under the null hypothesis is going to be 1 out of 9, or 11%. It's actually 11.11% if we want to be more precise. So our knowability reference distribution is just going to be 11.11% of the way up the number line. Okay, let us consider some questions here. So what is the scope of the inference for this investigation? Well, that's only going to, or just going to be patient EP here. What is the parameter value under H naught? Again, if we go back up and look at the H naught does not have the ability. That's how we build the reference distribution. So the parameter value under H naught is going to be 1 out of 9, which is 0.111 or 11.11%. So now let's rewrite the null and alternative hypothesis using our parameter. So the H naught again is no ability. So my pi value there is going to be that 11.11%. The alternative hypothesis is going to be pi bigger than that 11.11%. Again, if we go up and look at the alternative here, patient EP does have the ability. And if patient EP does indeed have the ability, then his probability of getting a correct test item should be higher than that 11.11%. Question 4, what type of test is this? Well, it's going to be a right-tailed test, because if patient EP is on the right end of this distribution, then they're going to have the ability, or he's going to have the ability. So if he gets most of these correct, if you or I were to take this test, we would probably get most of those items correct. So we would be up here on the high end of this distribution. So this is going to be a right-tailed test here. A right-tailed test. What was the outcome from the study? If we go way back up here at the top, the outcome for the famous faces test was 6 out of 25. So the outcome from the study sits here at 6. The values that I'm going to need to obtain when I'm getting the p-value are going to be 6, 7, 8, 9, 10, all the way up through 25, because this is a right-sided test. So what is the study outcome from the study? So patient EP got 6 correct out of 25. And what values are as extreme or more extreme than the study outcome that would support the research question? Again, that's going to be 6, 7, 8, 9, all the way up through 25. Okay. So now let us consider a statement that was made in the results section of this paper. And they're talking about the famous faces memory test here. So patient EP chose 6 faces correctly, so 24% correct. 24% is just 6 divided by the 25, which is marginally better than the chance score of 11.11%. So that's just the 1 out of 9 there. They're telling us that they did a binomial test, and also the p-value that they obtained was 0.052. So what I want you to do next, or what we will do next, you can hit pause and do this as well, is to obtain the reference distribution using Google Sheets for this situation. So again, we're going to create a column that goes from 0 up to 25. I should read 25 there, that's a typo. Should go from 0 up to 25. We're going to use the binomial distribution function, which is going to have an n of 25. Again, I'll fix that typo. But a pi value of 0.1111. Now the p-value that they are reporting is 0.052. So I want you to try to verify whether or not that's the correct p-value. Okay, so this is a show your work window. I created a short video to show you how to download and integrate or embed a Google Sheet into your notes. I'll go ahead and do the steps here just so that you can see that as well. So what I want to do here is create that binomial probability distribution in Google Sheets, but I want it embedded inside of our notes. So the first thing I need to do is obtain a copy of the spreadsheet. Let's go ahead and do that. Let's go ahead and give this a more reasonable name. So this is the Semantic Memory case study. I need a column that contains all possible values here for the number of correct. So that's going to go from 0 all the way down through 25. I don't have to type all of those in. I can just get that list started and then drag down here to 25. So that list needs to go from 0 to 25, and that's simply just the number line. And then I also need the binomial probabilities. So I need the binomial probabilities for each one of those outcomes. So here I can just type equal binom dist. I need the parentheses, so make sure to include the equal. I need the parentheses there. And then it's A2. It's the number of trials, which is 25. The parameter value, which is 0.1111. So that needs to be expressed as a decimal, not as a percent. So that's 0.1111 there. And then the last statement is false. That is the probability value of obtaining a 0. I need that for all of these. So if I just go in that lower right-hand corner and double-click, it'll copy that formula down all the way down to 25 for you. Okay, so how do I get the p-value? Or maybe I'll show you how to make the graph quick. I can do that, I guess, quick. And then I'll show you how to get the p-value. To get the graph, all I need to do is just highlight the possible outcomes and their probability values. Go underneath Insert, Chart. The default chart is a line chart. It's more typical to express this as a bar chart. So just change the chart type here to column chart. And there you have our reference distribution, our binomial probability reference distribution for the semantic memory case study. Now, to incorporate all of this work into your notes, what you're going to have to do is just share this document. Get the shareable link here. So just copy this. Come back over into our notes here. Copy that. And then open that file. And that file should appear here embedded within your notes. And you can actually work on that file from here as well if you want. So you can either work with that file over here on its own tab, or you can work on it embedded within the notes. Anything that you do inside of this embedded window will be updated in your Google Drive. Okay, so let's obtain the p-value. I guess I forgot to do that there. So to obtain the p-value, what I need to do is just highlight the values that are, let's go back up here a minute, highlight the values from 6, 7, 8, 9, all the way through 25. So I need to highlight the probability values from 6. So here's my number correct 6. I'm going to start here, and I highlight all the way down through 25 here. And when I do that, down here in the lower right-hand corner, okay, Google Sheets automatically sums those up for me, and you can see my p-value is 0.0519, or if I round that, it'll be 0.052. And that, I believe, is the same thing that they got when they did their analysis. Yes, it is. So I'll go ahead and let you answer the questions. So the p-value is 0.052. I'll let you go ahead and make the decision here, provide a conclusion. So let's move down here to after the conclusion. Consider again the statement that's made. EP chose 6 faces correctly, which was marginally better than the chance score of 11%. So I got a couple questions here. Why do you think the authors chose the words marginally better? And then question 9, do you believe there is some evidence to suggest? So this outcome here does not meet the 0.05 threshold. If we want to use it strictly, then it is saying that EP does not have the ability. But it's pretty close to that 0.05 threshold. So I might argue that there is indeed some evidence to suggest that EP has regained some ability for semantic memory or semantic knowledge. So example 2.6.2, what they did here is they actually combined the outcomes for the new vocabulary test, the famous names test, and the famous faces test. Okay, so there was 25, I believe, on the first test, 24 test items on the second test, and then 25 on the last. So that'd be a total of 74 test items. And patient EP got 12 correct out of that 74. So here are the statement that is made. EP scored 16.2%. Again, the 16.2% is just coming from 12 divided by 74, which is not reliably above the chance score of 11.11%. So the p-value here reported is 0.011. Not to be confused with the parameter value of 11.11%. Okay, I want you to complete the following steps. Go ahead and construct binomial probability distribution and just verify that probability value of 0.11 for me. This again is going to be a one-tailed right test. The study outcome here is 12. So when highlighting the p-values, you're going to want to go from 12 all the way up to 74. So I'll let you go ahead and verify that p-value calculation there. And again, use that embedded link so that shows up within your course notes. One last example down here at the bottom, example 2.6.3. So in the analysis done here by Bailey, the authors included outcomes from a second patient. That patient was patient GP. So the similarity between these two patients is that they both had decreased ability to retain semantic knowledge. They both had viral encephalitis. Now, patient GP did not suffer as much damage to his hippocampus as patient EP did. And it is believed that patient GP does have some ability to retain semantic knowledge. So the statement here, the first part of it is just what we considered up above, that patient EP was not reliably above the chance score of 11.11%. However, for patient GP obtained 41.9% correct. So patient GP, when they combined the results from all three tests, got 31 items correct out of the possible 74. So patient GP's p-value is considerably smaller than that of patient EP. 2 research questions posed here. I will let you write the conclusions for those 2 research questions. And then finally, question number 12 is asking about, do those p-values or do the outcomes from this study tend to support the notion that patient GP does better than patient EP? So I want you to do that from a statistical point of view here. Do more than just say, well, patient GP got more correct than patient EP. Statistically speaking, can we say that patient GP is better off in terms of his semantic knowledge than patient EP? Okay, that does it for part 2, or module 2, part 6. Thank you.